So question 14, we're looking for the correct units for the rate constant. So a reminder, the rate constant is K. So the first thing we need to do is rearrange the equation to make K the subject. So K is equal to rate over the concentration of A squared times the concentration of B. So now we think about what units we would have for K. So the units for rate is always a mole per dm cubed per second. And if we combine all the units for concentration, we get mole to the power of 3, dm to the power of -9. And then we can cancel one of these mole terms, top and bottom, which leaves us with mole to the power of 2 on the bottom. And we can cancel one of these dm to the -3 terms, top and bottom, which leaves us with dm to the -6 on the bottom. That leaves us with this, which we need to tidy up. So when we bring values from the bottom of a fraction up to the top, we reverse the negative or positive signs of the power. So what we'll end up with is mole to the power of -2, dm to the power of 6, seconds to the power of -1. So we look at those answers, the one that matches is D, so our correct answer is D. Finally, we have an equilibrium problem here in question 15. So I think the best thing to do here is to use our ICE method. So that stands for the initial concentration, change, and the equilibrium concentration. So our initial concentrations we get from the question here. So we've got 1 mole of propanoic acid, 1 mole of methanol, no moles of methyl propanoate, and 2 moles of water. So we've been given some information about the solution when it reaches equilibrium, and that's that we have 0.5 moles of propanoic acid. So that's a change of -0.5, which is the same for every compound in the equilibrium. So all the reactants will reduce by -0.5 moles, and all the products will increase by 0.5 moles. So do some simple subtractions and additions to work out the molar quantities at equilibrium. Now, because all these substances are solutions, we don't need to worry about the volume because the volume will cancel out. So we don't actually need to worry about calculating concentration. We could put moles straight into our Kc calculation. So Kc here would be equal to 0.5 times 2.5, so that's the mole values of the products, over the mole values of the reactants, and 0.5 times 0.5. So if we put that into a calculator, we get an answer of 5 for the Kc. So the correct answer here is C.